Okay, so we're going to factor again. This is yesterday's. Let me get past that. Okay, so we're going to factor. We're going to talk about a couple of other ways to factor, and then how do you know which method to use when they don't tell you. All right, so we're going to factor a difference of squares. They work with a nice little pattern. It's always two binomials. You know you have a difference of squares when it's a different subtraction of perfect squares. And it's always going to work out to their square roots. Add one, subtract on the other. And the reason that you do that is you're trying to get 0 in the middle. So if you think about it like the guess and check method, you know you're getting x squared, you know you're getting negative 64. Your outside, inside will give you a negative 8 and a positive 8, which gives you nothing in the middle. All right, so for the next one, same thing. You know you want a positive and a negative of the same parentheses. You want the square root of 36, which is 6, in the front, and the square root of the 49, which is 7, in the back. And whatever their variable is, that goes with it. Now it has to be squared or to an even exponent. All right, so for a sum or difference of cubes, those also follow a pattern, but they follow a little more complicated pattern. So for squares, going back to the previous two examples, that only works with subtraction. If you have perfect cubes, you can factor that with addition or subtraction, which is why it says sum or difference of cubes. So here we have a difference of cubes. Here we have a sum of cubes. All right, those are always going to follow a pattern too, but it's going to be a binomial and a trinomial. All right, so the binomial is just going to be their cube roots and whatever sign is in between. So cube root of x cubed is x. Cube root of 64 is 4. Keep the minus sign. All right, so then we're going to follow a pattern to get this one. So we're going to take this and times it by itself. Take this and times it by itself. So it's always going to be a plus here because you're doing something times itself. Then you're going to multiply these two, which would be negative 4x, but change the sign. So we'll make it a plus 4x. So for number 14, binomial, trinomial, because we have a sum of cubes. Cube root of 27, x to the third is 3x. Cube root of 125 is 5. Keep that sign. To get the trinomial, you're going to square this guy. Square this one. Always a plus on the end. And you're going to multiply these. That would be 15x, but change the sign. So when we write it down, we're going to make it a negative 15x. So again, use their cube roots with the same sign, and then square the front, square the back, multiply the two things together, but change the sum. All right, so next, if you're told to factor completely, that means you have to look to see if there's a GCF. If there is, take it out. If there's not, move on to step 2. Step 2 is looking at what you have in parentheses if you took out a GCF, or just looking at the problem if there was not a GCF. How many terms do you have, and then factor accordingly. So if there are 2 terms, it's either a difference of squares or a sum or difference of cubes, or you're done. If you have 3 terms, you're going to try to guess and check. If you have 4 terms, we're going to use grouping. All right, so here are some examples of that. I'm trying to make it a little bigger. Hold on. Okay. All right. And we're going to skip number 4 because I don't know what I was thinking when I wrote that problem. I realized that yesterday when I did this with my other class, but I forgot to fix it. All right, so number 1. What do we have in common? Because we're always looking for a GCF. So what do 10x to the third and 4x squared have in common? Well, 10 and 4 are both divisible by 2, and I can take out x squared because that's the smallest amount of x's. So then 10 divided by 2 is 5, and they need 1 more x. 4 divided by 2 is 2, and it's going to be negative 2, and the x's are already what they need to be. All right, so look at this. Those are both prime numbers, and this is not squared, so you know you're done. All right, number 2, you have no GCF, and I know that because he doesn't have a variable and he doesn't have a number. So that's your clue, there's no GCF. All right, so then look at how many terms you have. You have 4 terms. So that means factor by grouping. So remember, we're going to group the front 2 and take out what we can take out. Some days I really do wonder about myself because this problem doesn't work either. Hold on, give me a second and I'll make it work. How about that? Okay, so we're going to change the problem to, I want it to be 9x to the third minus 36x squared plus 20x plus 100. We'll make that minus 100. All right, so let's try this again. Group the front 2. All right, so now these are both divisible by 9, and I can take out x squared. So that leaves me with an x when I divide these, and when I divide these, I get negative 4. So then we group the back 2. Those are both divisible by 20. Divide here, you get x. Divide here, I can't do math. Mercy. You get 5. All right, so at this point, you would stop and say that it's prime. It does not factor. That's not what I intended to happen. What I intended to happen was for this to work out to be a 4. So let's change the 100 to an 80. If you are thoroughly confused at this point, I apologize. All right. No, really. Change to an eraser. Okay. Try and one more time. Okay, so my original problem was garbage. It had too many extra letters in it. The next problem that I made in my mind, I said that 20 went into 100 4 times, so I made up a problem that would get a 4. Well, obviously it doesn't. So 20 does go into 80 4 times. All right, so now that we're back on track, we grouped the front 2, took out a 9x squared. Grouped the back 2, took out a 20. Now we have matching parentheses. So you can take out that x minus 4 and have 9x squared plus 20 left. Okay, I think the rest of these really do work. How many are there? Okay. All right, so number 3, you have, let's see, is there a GCF? We have x, no x, and 3, 13, and 4. So there's no GCF because you can't take something out of 3, 13, and 4. So it's got 1, 2, 3 terms. So we're factoring a trinomial. So what can I multiply to get 3x squared? Well, I think 3x and x. All right, what can I multiply to get 4y squared? Well, I think 2y and 2y. That's my guess. All right, so if I think about what this is going to get me, I'm going to get 6 and 2. Well, 6 and 2 will not get me to 13 by adding or subtracting. So maybe I should use a 4 and a 1. And I'm going to put the 4 here because if I multiply 4 by 3, I get 12, and that gets me close to 13. This is positive, so these two signs have to match, and this guy says make them negative. All right, so now we double check and make sure that my thinking was correct. This is negative 12xy. This is negative 1xy. So I have negative 13xy. So we are done there. Always remember to check at the beginning for a GCF though. All right, we're skipping number 4 because that was a hot mess. All right, number 5. All right, so if you look at number 5, that again does not have anything in common. A 6, a 19, and a 7. But there's 3 terms, so we know we can try guess and check. So to get 6x squared, maybe a 3 and a 2 should work. All right, what about multiplying to get negative 7? I think you have to use 7 and 1. Maybe if I put the 7 here and the 1 here, that'll give me 21 and 2, which will give me 19 if I'm subtracting. And I need a negative, so I do need a negative and a positive. So we'll say positive here, negative here. So you've got 21x and negative 2x, which is 19x. Now remember, I'm thinking ahead of myself to see if I think it'll work so that I get the right answer on the first try. That's not always going to happen. You don't have 25 years of experience factoring. So if you don't get it right the first time, don't get frustrated. Just pick some other numbers. All right, so looking at this, I believe those three things are all divisible by 2. So my first step is going to be making the screen come back because I hovered over the wrong button too long. Okay, so GCF of 2. So that leaves x squared minus x minus 6. All right, so you can't just stop after you take out a GCF. You've got to look to see if what you have there will factor. So we're going to try to factor this. This 2 is just going to slide down and hang out. We're factoring this guy into these parentheses. All right, so we know to get x squared, we need x times x. We know to get 6, we can use 1 and 6 or 3 and 2. We need a positive and a negative. This guy is negative, so I'm going to make the big number negative and see if that works. All right, so I'm going to get positive 2x, negative 3x. That does give me my negative x. So I know that I have the right answer. So this is my final answer. Factor completely just means take out the GCF and then keep factoring if you can. All right, number 7. All right, again, do we have a GCF? I believe that those are all divisible by 3. And they all have an x. So that's going to leave me x squared. Divide here, and you're going to have negative 10x. Divide these, and you're going to have 25. All right, so then we try to factor this and keep up with that GCF. All right, so for x squared, you need an x and an x. For 25, you need, let's say, a 5 and a 5. And they need to both be negative because this is positive saying have the same sign. This is negative saying make them negative. So we get negative 5x, negative 5x. That does give me negative 10x. So that's it. All right, number 8. Let's see, 16, 56, and 49. I was thinking there was a GCF, but 49 is not divisible by 2. Or 4. So I'm thinking no. So just factor the trinomial. A tip that I have that I didn't tell you yesterday, when you notice that these are both perfect squares, I would use their square roots because that will 9 times out of 10 be what works. All right, so we want a 4x and a 4x and a negative 7 and a negative 7. Again, this guy is what tells me to make them both negative. This says make them match. This says make them both negative. All right, so this is negative 28 and this is negative 28. And negative 28 plus negative 28 is negative 56. So remember that when it's the exact same thing, you can write it as parentheses squared. All right, 2 more. Let's see, there is no GCF here, so we're just going to factor. It's 2 terms, it's a difference, and these are perfect squares. So I know I need 2 binomials. I need 1 add, 1 subtract. The square root of 81 is 9. The square root of x to the 4th, you always just half the exponent, so it'll be x squared. So you got 9x squared in the front. 16 square root is 4. All right, so normally you would think you were done, but we're factoring completely, which means make sure that you can't go any farther. So this is a sum of squares, so it won't factor. Keep it. This is also a difference of squares. You have a difference, and these are both perfect squares. So you can factor that guy down again. He'll be a 3x plus 2 and a 3x minus 2 because that's the square roots of 9 and 4. So this is our answer. All right, number 10, you have a difference of perfect cubes. So you need a short and a long. Cube root here is 5x, and the cube root here is 2, or negative 2. So you're going to square the terms, and then you're going to multiply them together and change the sign. This will never factor again. Sometimes this might accidentally, but this one is not going to. All right, so on your assignment, it's just a bunch of problems. Well, you have two sections, I think, where it says do the difference of squares, and then do the sum or difference of cubes. And then you have a section where it just says factor completely. So that's where you have to use those steps that I gave you a few minutes ago. Take out a GCF if there is one. Look at the number of terms you have and decide what kind of factoring to use. Usually, you're not going to have to factor. After you factor the trinomial, you won't have to factor again if you took the difference of squares of the wrong term, the GCF out in the first place. But just always before you stop, inspect what you have and see if you think it'll factor again. All right, again, there are videos under resources with some more factoring help. You are welcome to email me with questions. I really don't mind making a special video to show you how to do a certain problem that you're struggling with. Just let me know.